All right, let's talk about something we all use pretty much every single day, but probably don't think much about: the asphalt under our tires. Today we're diving into the surprising science of what makes a road smooth and what makes it, well, not so smooth.
You've definitely been there, right? You're driving down a road that feels brand new for years, and then you turn onto another one that's a total disaster, full of potholes just a year or two after it was paved. It's not just bad luck. It turns out it's all about science. And today, we're going to pull back the curtain on the science that makes all the difference.
And the stakes here are pretty high. I mean, look at the difference. A durable road, that's a smooth, quiet, and safe ride that lasts for a long, long time. But a failed road, that's where you get the potholes, the spiderweb of cracks, and those really dangerous ruts that can form where the wheels always go. The gap between these two outcomes isn't an accident. It's determined by a very precise process.
So, let's start with the big question. Section 1. Why do roads fail? As you're about to see, building a road that lasts isn't just about dumping some black stuff on the ground. It's a high-precision procedure where every single detail matters.
You might be surprised to hear this, but asphalt paving is actually one of the most tightly controlled processes in all of construction. A road's entire life depends on getting three things absolutely perfect: the recipe of the mix, the temperature during paving, and how well it's compacted. If you mess up even one of those, that road is pretty much doomed from the start.
Which brings us to Section 2, the perfect recipe. You can think of it just like baking. If your ingredients are off, it doesn't matter how well you cook it, the final product is just not going to work.
And asphalt, at its heart, is a really simple recipe with just two main ingredients. A whopping 95% of it is what we call aggregates. That's just a fancy word for crushed stone, gravel, and sand. This is the muscle, the structural backbone of the road. And that other 5%? That's the binder, the super sticky, high-tech glue that holds all that muscle together.
But here's the thing, you can't just use any old rocks. These aggregates are carefully engineered. They need to be angular and sharp, not smooth and round, so they can physically interlock like tiny puzzle pieces for strength. They also have to be incredibly hard to stand up to the wear and tear of traffic, and durable enough to not get crushed under the weight of heavy trucks. It's a really specific shopping list for what looks like just a pile of rocks.
And the glue? Well, the glue is even more high-tech. Modern binders are called performance-graded, or PG for short. This means they are literally designed for a specific climate. So if you see a binder called PG 5828, what does that mean? It means it's built to handle pavement temperatures up to a blistering 58 degrees Celsius without getting soft and gooey, and it will stay flexible all the way down to a freezing minus 28 Celsius without cracking. It's basically a custom-designed glue for every environment.
Okay, so you've got your perfect recipe. Awesome, but now you have to cook it and get it all the way to the construction site without messing it up. And this, folks, is the high-stakes journey from the plant to the paver.
It all starts at the plant. The rocks are dried and heated up to over 150 degrees Celsius. Then they're mixed with that liquid binder glue we just talked about. From there, the hot mix goes into these massive insulated silos, kind of like giant thermoses, before being loaded into trucks. And those trucks absolutely have to be covered with tarps. Why? Because they're protecting the single most important and most fragile ingredient of all: heat.
And here's why that heat is so critical. Asphalt has an incredibly narrow temperature window for it to work. It leaves the plant scorching hot, right around 160 degrees Celsius. By the time it's being laid down by the paver on the road, it still needs to be above 135 degrees. But here's the real kicker. The compaction, all that rolling, has to be completely done before the asphalt cools down to 90 degrees. Any colder than that, and it becomes too stiff to work with, and you can't get it dense enough to last. This quote really says it all. The battle against heat loss is constant. A long haul from the plant, a delay at the job site, heck, even just a cold and windy day can be enough to turn a perfect mix into a total failure before a single car ever drives on it.
All right, now for the grand finale, the final make-or-break moment in a road's entire life: compaction. This is what we call the critical squeeze.
What's this number? 92%. Burn this number into your brain, because it is arguably the single most important number in the entire world of paving. It is the target, it is the goal, it's the minimum passing grade.
So 92% is the minimum required density of the asphalt. The whole point of compaction is to squeeze out all the tiny air pockets or voids, which are basically weak points in the pavement. If you can get that asphalt squeezed to at least 92% of its maximum possible density, you lock all those rocks together and create a waterproof, super strong surface that can fight off rutting and cracking for years and years.
And getting to that magic number isn't just about driving a roller back and forth. No. It's a carefully choreographed dance. It starts with massive, heavy breakdown rollers that do the initial heavy lifting. Then, intermediate rollers, often with big rubber tires, come in to knead the asphalt and get all the particles lined up just right. And finally, finish rollers come through to iron out any marks and give it that perfectly smooth surface we all love. It's a synchronized ballet with multi-ton machines.
So, with all these incredibly critical steps, how do we actually know if the crew did the job right? Well, that's where the quality auditors come in to issue the project's final report card.
Now, if any of those key steps, the recipe, the temperature, or that critical squeeze, fail to meet the super strict specifications, an auditor issues something called a non-conformance report, or an NCR. You can just think of it as an official failing grade for that section of road.
Let's look at a real-world example of one. In this case, the observation was that the density was below that magic 92% number. The impact? A high risk of the exact problems we talked about earlier, rutting and water getting in and destroying the road from the inside out. And the disposition is simple: rejected. The work is not accepted until it's fixed and passes the test.
Here's another really common one. The observation: the asphalt was too cold when they started rolling it. And the direct impact of that? They couldn't get enough compaction, and the layers of asphalt didn't bond together properly. The order is clear: stop work. These reports aren't just suggestions, they are the enforcement that separates the good roads from the bad ones.
So, the next time you're stuck in traffic and you see a paving crew up ahead, I hope you'll see something a little different. You're not just looking at a simple construction site, you're watching a high-tech, mobile laboratory in action, where a precise recipe, critical temperatures, and a perfectly timed squeeze are all coming together to create the smooth, safe roads we all depend on.